Welcome to Thinking Geographically. In this video, we'll explore how geography shapes our understanding of the world. Geography isn't just about maps and places, it's a way of thinking that helps us analyze patterns, relationships, and processes across Earth's surface. Whether you're curious about how cities grow, why cultures differ, or how technology connects us, geography provides the tools to investigate these questions. Let's dive into the basics and see how geography as a field of inquiry has evolved over thousands of years, influencing everything from trade routes to modern technology. Geography has a rich history, stretching back over 3,000 years. Early geographers like Eratosthenes and Ptolemy laid the foundation for mapmaking or cartography by measuring and mapping the world with impressive accuracy. Their work was crucial for navigation and trade, helping travelers find their way across unknown lands. Over time, geography evolved from a practical tool for explorers to a sophisticated academic discipline. Today, it combines both scientific and artistic approaches to understanding our planet. Eratosthenes, the head librarian at Alexandria, was among the first to calculate Earth's circumference with remarkable precision. He also coined the term geography, meaning earth writing. Centuries later, Ptolemy published his Guide to Geography, introducing rough maps and a global grid system. These early achievements not only advanced cartography but also deepened our understanding of spatial relationships, setting the stage for future geographic discovery. During the Age of Exploration, European explorers like Columbus and Magellan mapped new territories, climates, and cultures. Their journeys integrated geographic knowledge from around the world, helping to establish geography as a global science. The influx of information led to the development of new academic disciplines and theories, such as Darwin's theory of evolution and Wegener's theory of continental drift, both of which relied heavily on geographic data. By the 20th century, geographers like Carl Sauer emphasized the importance of cultural landscapes, how humans shape and are shaped by their environments. This led to the study of environmental geography and cultural ecology, focusing on the dynamic relationship between people and nature. Today, geography examines not just the physical world, but also the complex interactions between societies and their surroundings. The mid-20th century, geography underwent the quantitative revolution, embracing empirical measurements, mathematical models, and computer technology. This shift allowed geographers to analyze spatial patterns more rigorously, using data and statistics to explain how and why certain phenomena occur where they do. The integration of technology has made geography more precise and powerful than ever before. Today, geographers use advanced tools like remote sensing, GPS, and geographic information systems, GIS, to collect and analyze spatial data. Remote sensing captures images of Earth from satellites and airplanes, revealing patterns in soil, water, vegetation, and human structures. GPS provides precise location data, while GIS allows for the layering and analysis of multiple types of information, helping geographers understand complex spatial relationships. Geography is a diverse discipline, divided into human geography, physical geography, environmental geography, and geographical techniques. Human geography studies human activities and their spatial patterns, while physical geography focuses on Earth's natural systems. Environmental geography bridges the gap between the two, examining how humans and the environment interact. Geographical techniques include the tools and methods used to analyze spatial data. Thinking geographically means adopting a spatial perspective, analyzing the relationships among places and the patterns that emerge across space. Geographers ask questions like, why are certain things located where they are? How do places interact? For example, why are McDonald's restaurants found in some countries but not others? This perspective helps us understand both the uniqueness and the similarities of different places. Scale is a key concept in geography. Map scale refers to the ratio between distances on a map and actual distances on Earth. Geographic scale, however, is broader. It refers to levels of spatial organization, from neighborhoods to regions to the entire globe. Understanding scale helps geographers analyze how processes at one level can impact others, such as how local pollution can have global effects. Regions are areas that share certain characteristics, whether physical, cultural, or both. Geographers use regions to group places for easier comparison and study. Regions can be formal, functional, or perceptual. Formal regions have uniform features, functional regions are defined by connections, and perceptual regions exist in people's minds. Understanding regions helps geographers analyze patterns and identities across space. Let's look at the three main types of regions. Formal regions have consistent characteristics like Tibet's shared culture and landscape. Functional regions are tied together by connections, such as the San Francisco Bay Area's economic and social links. Perceptual regions like the American Deep South exist in people's minds and are shaped by history, culture, and stereotypes. Each type of region offers a unique way to analyze space. Geographers describe location in several ways. Absolute location uses coordinates, latitude and longitude, to pinpoint a place on Earth. Relative location or situation describes a place's position in relation to other places. Site refers to the physical and cultural features of a place itself. Understanding these concepts helps us analyze how places are connected and why they matter. Distance can be measured absolutely, like miles or kilometers, or relatively, considering time, cost, or social connections. Connectivity refers to how places are linked economically, culturally, or politically. Sometimes places that are far apart physically are closely connected, while nearby places may be less so. Advances in technology have shrunk relative distances, making the world more interconnected than ever before. Spatial processes explain how and why things move or interact across space. Concepts like complementarity, intervening opportunities, and transferability help us understand trade and movement. Accessibility and friction of distance affect how easily people, goods, and ideas move. The gravity model shows that large cities can have strong interactions even if they're far apart, thanks to their size and influence. Friction of distance leads to the distance decay effect. Interactions decrease as distance increases. However, diffusion processes like contagious or hierarchical diffusion show how ideas, trends, or diseases can spread across space. Expansion diffusion keeps the phenomenon in its origin while spreading outward, while relocation diffusion involves people moving and bringing their culture with them. Apps are essential tools for geographers. They come in many forms: reference maps for navigation and thematic maps for displaying data. All maps involve projections, which inevitably distort some aspects of reality. Cartographers must choose the right projection, scale, and level of detail to best communicate their message. Understanding map fundamentals is key to interpreting spatial information. Different map projections serve different purposes. The Mercator projection preserves direction but distorts size near the poles. The Peters projection treats all regions equally in area, while the Fuller projection maintains size and shape but rearranges direction. The Robinson projection balances errors, and azimuthal projections offer a unique top-down view. There's no perfect projection, each has its strengths and weaknesses. Map scale is the ratio between map distance and real-world distance. Large-scale maps show small areas in detail, while small-scale maps cover large areas with less detail. Resolution refers to the smallest feature visible on a map. Choosing the right scale and resolution is crucial for accurately representing spatial patterns and making meaningful analyses. Apps use various symbols to represent data. Isolines show equal values, proportional symbols indicate magnitude, dot maps display occurrences, choropleth maps use color to show categories, and cartograms resize areas based on data values. Visualizations and cognitive maps add new dimensions, helping us understand both objective and subjective aspects of space. Geography is more relevant than ever in addressing global challenges. From analyzing population growth and environmental change to planning cities and responding to disasters, geographers use spatial data to inform policy and solve real-world problems. Advances in technology have expanded the possibilities for geographic research, making it a vital field for the future. Sum up: thinking geographically means adopting a spatial perspective, understanding scale and regions, and using maps and data to analyze patterns and processes. Geography connects the physical and human worlds, providing insights into how places are linked and how we can address the challenges of our changing planet. Keep exploring, keep questioning, and remember, the world is full of patterns waiting to be discovered.